Hello grade 11s, this is Physical Science. My name is Gillian, and today we are going to strip away all the confusion around friction, and we are going to get to the nitty-gritty of it to help us to see it more clearly. So we are exposing friction today. So let's have a look at what causes friction. So on my board I have an overview. We have the cause of friction, and then we have the two kinds of friction. There's static and kinetic. So what causes friction? Well, when we have two surfaces that are rubbing together, then we have friction. The output of friction is heat, so things get hot. And you will know this if you've fallen on the grass and you've slid. It burns, you get a grass burn. Okay, so that's two surfaces, your knee, your skin, rubbing along the grass, they're interacting, they're rubbing together, there is friction, and there is a burn, it gets hot. So that is what friction is. It's a force of friction, and it causes an increase in temperature in those surfaces. There are two kinds. The one is static. And as it says, static is stationary, so that is the friction that will occur when something is not moving yet. And then we have kinetic friction, and that says exactly what it is. Kinetic is moving, like kinetic energy, it's moving energy. So when something is moving on a surface, there is friction that retards that movement. What about friction? Because friction is quite a tricky force. Well, we would think that it is dependent on how much of your knee is on that grass. In other words, the surface area comes in contact. But that would be incorrect thinking. In actual fact, friction is independent on the surface area that is in contact with the second surface. So here I've said area does not influence, it has no bearing on the size of the frictional force at all. What does have a bearing on the size of the frictional force is the mass of the object. And so the more mass an object has, the greater the gravitational force, and so then the frictional force is going to increase. So frictional force is definitely dependent on the mass of the object. The other thing that friction is dependent on is the type of surfaces. So if you think about smooth surfaces versus rough surfaces. So example, the tarmac is quite rough. So tires on tarmac, okay, so a tire is also quite a rough surface, that rubber is quite rough. That would affect the amount of friction or the size of friction between those two surfaces. If you've got a smooth surface, then those surfaces would then have less friction between them, but they still will have friction. So the type of surfaces will give us a frictional force of some size. So it's dependent, the size of the frictional force is dependent on the types of surfaces that are rubbing together. Okay, so let's have a look now in detail around this frictional force and what it, we can break it up into static and into kinetic friction. So a long time ago, before you were born, in 1985, there were restrictions around the amount of petrol that Formula One racers were allowed to use. And they restricted that. And all of a sudden, all these drivers were running out of petrol, and they got out of their vehicles, their Formula One cars, and they pushed them to the finish line. So I want to use that example today. So if you look on my screen, you will see this Formula One car that's sitting here. Now, this thing is just sitting there. There is no one pushing it. There is no applied force. And because there's no applied force, there is no friction. Have a look there. That's the first thing we need to bear in mind. No applied force, no friction. The static friction, this is stationary, so we're dealing with static friction. There is no static friction, it is equal to 0. There's no person pushing it, there's no applied force, it is 0. Static friction is 0. Now what happens, our driver gets out, I'm going to draw him in. Okay, so here's our driver, just excuse my drawing. Okay, there he is, okay. He obviously has to be over here because he's got to steer the car so it doesn't go off the track. And he starts to push. However, the car does not move. Now, if you go and watch these old videos, you'll see the driver gets out and he's starting to push and there's no movement. But because there is an applied force, here's the applied force, he's pushing against the wheels. Okay, the applied force, he's pushing against the car, he's pushing it to move it, there's an applied force. There is frictional force, and it is static frictional force. As he pushes, he's going to increase that applied force. Obviously, he's going to push harder and harder. And the amazing thing happens, as he pushes harder, the static frictional force matches that. And so as you increase the applied force, the static frictional force increases. And so this over here, static force matches the applied force. The car is still not moving. It gets harder and harder to push that car. And then all of a sudden, that car starts to move. At that point where the car just starts to move, the object is starting to move and the static force is just overcome by the applied force. So if the object then starts to move, just as it starts to move, that static frictional force is overcome and the static frictional force will be at its maximum. That's the maximum it can ever be. Interesting, isn't it? So let's have a look how we can put this into words. So we've got static friction. What is it? It is the force that is stopping movement. So friction always works in the opposite direction to movement. It opposes, have a look there, it opposes, it goes against the tendency to move. Why only the tendency? Because this object isn't moving, but it is intending to move. So the applied force is being applied, it is intending to move, and so it is the tendency of motion of a stationary object. It is something which is static. It is not moving yet. It has to be relative to the surface. So that is the definition for static friction. We write the maximum static friction. Remember, that's just as the car is starting to move or the object starting to move. We write it like this. It is a curly F with a little s. That S denotes, it tells you that it is static friction. The curly F tells you it's friction. And then there is the word max. So max means that is the maximum amount of static friction just as the car is starting to move. So how are we going to write this or draw this on a graph? So in science, we like drawing on a graph. We like to see the relationship. It is a picture of the relationship. And on the x-axis, I have applied force, because what we're doing is we are applying the force. The driver is pushing the car harder and harder and harder. So we can then measure the applied force. What is then happening to the dependent variable? And the dependent variable will be this force of friction that is placed on the y-axis, the dependent variable. Well, it increases and it matches. So as the applied force is increased, can you see that? Increased. So the frictional force is going to increase. And it increases, you can see this line, it is a straight line, and it increases to a point. So we'll come to that a little bit later. We'll finish up this graph. But you can see that this relationship is a proportional relationship. As the one increases, the other is going to increase. So here I have this section from the naught value to over here, to where we finally reach the maximum static friction. And this part is equal to the applied force. So as the applied force increases, so the static friction increases, and we get this relationship here. Right. Now this picture is of a driver that's actually driving it. So you can see the background. You can see it's moving fast, right? So you're going to just ignore that for now. We're going to pretend that our driver is now pushing this vehicle. Okay, he's pushing. There's my driver, he's pushing. And it is now moving. So he's pushed, it hasn't moved, and then all of a sudden the vehicle starts to move, the car starts to move, and that becomes easier. If you've ever tried this, if you've ever tried pushing something and it's really, really hard, and then all of a sudden it's almost as if something gives way and then it starts to move more freely. What happens is, as it starts to move, the static friction is overcome and another type of friction takes over, and that is the kinetic energy. Kinetic friction. So the kinetic friction is the friction that is opposing the movement, but it is less. It is much less than the static friction, and it is less than the applied force. Okay, so it's less than the applied force. Becomes much easier then to push that car. So if we look at our graph, what's happening here? Well, we see that we've reached the maximum. There we showed that in our last one. We've reached our maximum, and then all of a sudden that car is moving, and it's moving much more easily. So there is a drop in friction and the kinetic friction. So it drops, that's the drop down here, this purple line. And then look at it, look how much less it is. Okay, you can see the frictional force, it's much less than the maximum static frictional force. So the kinetic frictional force is much less. And look at it, it's a straight line. It is constant. Okay, so it is a constant value for the movement of that vehicle. Grade 11s, we are going to take a quick break, and then we're going to look at what affects this frictional force. If it's not the area, then what is it? Right, I'll see you after the break.